From this application, and I'm gonna show you how to process Micasense data using the DROACOR software. And we assume that you get a calibrated Micasense system, so we can go directly for the import at first. So we want to import the Micasense data directly into DROACOR. So we start on the original imagery, which is maybe sitting in such a directory like this set here. Now you have these TIFF files, individual TIFF files, and in here there are apparently 200 data files with 5 bands each. We want to co-align them first into 5-band imagery to make them accessible for the atmospheric correction. So we create a camera file, and for the creation of a camera file we can select just one in between, so maybe I can take just 100, and this is a reference image to be used to co-align all the images into one co-aligned image. I'm gonna define the camera file for this. Maybe I say it's camera set from band 100, and now I'm gonna calibrate this so it will arrange all the 5 bands against each other and do a correlation analysis and a matching, and tries to find a polynomial function to co-align them properly. After this has been done, I can use this camera file. So I can select that one. I've just created that one in camera 100, that's this one, to import all the data. I assume I got the calibration already done before. If you don't have the calibration file, you can use a default calibration, or you can go for the in-flight calibration, which is explained in a different video than that one. So I got some calibration information available here. I'm gonna go a little bit further up, and I'm using this calibration file. So that's that's okay. I'm using a global digital elevation model for ground altitude. One could also use a constant elevation of the ground. Well, constant elevation maybe is better for this data set if you already know it. So we assume it's being 650 meters above sea level, and so it can import the data. I don't start the import process because it takes 1 or 2 minutes now, but if it's imported, it will look like that. So I can show you the output of the import function. I imported it to a different directory, somewhere in here, to set into the reflectance, and then you get some imported data like that one. And so these are co-aligned 5-band images with some black background, but that's something which is not a concern. So you can look at the values. So it seems to be fairly reset range, so it seems to be reasonable radiances, so this can be used for the reflectance retrieval now. In a second step after this import, I can go directly into the reflectance processor. So I'm using these images which has been created, so I'm pushing here a filter. So for instance, image.psq. So these are the import images which have been created. Maybe I go to I have more here. Here are the images. Okay. And I have to make sure that I push the filters correctly, such that really the files I want to process are displayed below. So if I select this thing, yeah, that's still okay. But you could just be careful to select the correct files here. The reference images would be used if you got a variable integration times or something, so it would be adjusted with respect to this reference image. And the only thing you have to select then is the output directory of the reflectances, and so it will do the reflectance retrieval. I don't start it as well here because it also takes a while, but I can show you the output of the reflectance retrieval. So I can show you some reflectance output. So here is an input, and it had written the output directly beneath it. By the way, these are env files, so we are relying on env data formats. And if looking at the data, this is quite a reasonable reflectance. So you get 5 or 10% in the visible and a little bit brighter in the near. If you go to brighter vegetation, this is what could be expected for vegetation. This is then done for all the images. This has had some shadow, but it's a different question. So this is done for all the images. And now the question is how to feed them into Metashape. And feeding them into Metashape is quite easy. So the only thing we need to do is to export the data to a Metashape data format. So Metashape can digest TIFF files, also multiband TIFF files, and there's a function in DROACOR such that I can export Micasense TIFF file. So file export Micasense TIFFs, and I select the reflectance. All the reflectances, so l.bsq, and I also select the base directory of Micasense. The base directory is where the original TIFFs are, because the metadata is taken from there. So the metadata is taken from the original TIFFs, and the reflectances, so these two are joined into new TIFFs. And here it's the, I should put it to a TIFF, reflectant TIFFs here, and it will create the TIFF files. So these are TIFFs which are now accessible to Metashape. So if I'm exporting them, it will create all TIFF files as expected. This is the last step in DROACOR before going into Metashape. So if looking into Metashape, I already have prepared this for you. Here is how it looks like in Metashape. This whole campaign I imported all these TIFFs. So the import is done just by add a folder, and then you add this TIFF directory. So that's these TIFFs here, and it will import it as a single camera, and this could be done then, and it will add all of them. So now they have been added twice. That's a different issue, but it's possible to add all this data directly from this TIFF which has been exported from DROACOR. And now in the processes, in the workflow of DROACOR, of course you go to the normal workflow, you align the photos, you build the dense cloud and so on. And if you build the mesh, that's fine, that has already been done here. And you build the auto mosaic, for instance. And for the auto mosaic, you have to be careful to use here in the blending mode a disabled, because if you choose mosaic or average, the radiometry of the data is changed by Metashape, and you want to have a coordinate system, a metric coordinate system, of course, and you should disable the blending mode, and everything else can be kept as is. Of course, you can give a region and so on, and everything else remains as known from Metashape. Now we could run it, and it would create the auto mosaic. I can afterwards finally export the auto mosaic to a TIFF file, and if I'm looking at the TIFF file from within DROACOR, that's what you get as a result. And this is for this campaign, what's the output of the Metashape processing. I got some gaps, I got a little bit of shadow up here. So it didn't, as you see, it didn't adjust the brightness at the borders, but it has the original reflectance data. If you compare this one to the standard Metashape processing, this makes quite a difference. So I did the very same with Metashape, and that's how it looks like there. And you see there is a problem that the adjustment of the brightness during the mosaicing makes a distortion onto the radiances. So you don't have a uniform radiance output if you do it with the Agisoft standard processing. So this helps quite a lot to have standardized reflectance or homogenized reflectances before feeding it into into Metashape. Now for the final thing is you want to have, for instance, NDVIs, and there also you see there's quite a difference between the two. That's what I'm going to show you. I got the NDVI first calculated from the original image. That's how it looks like. And the same for the new image. And these are co-aligned, push position, and I'm getting the position here. So they are at the same position, but apparently it's very different. So after the DROACOR processing, you see the individual crowns of the trees very well, and that's how it should be. You should see the crowns, but in between these are shaded areas. They shouldn't be such high. So if you don't do a reflectance retrieval and just run NDVI in forests, you get quite some mistakes, and it's not as it should be. You can also compare to the if you want to see what the original image looks like, it's further up. So that's the reflectance file here. Yep. I'm also going to this position. That's how, just to show you that you're really at the in a shaded area where this sample was. Okay. Some artifacts there, by the way, have been corrected in the meantime. I just have selected the wrong file. Maybe to select a better one, that one. So now I have the right edge as one band, get position, and this is again where you are, and that's how the NDVI looks like if you have a standard processing, and that's how the NDVI looks like if you do it through the DROACOR and through the reflectance retrieval, and this is much more reasonable than what you had before. So this shows you that reflectance retrieval based on calibrated data makes a huge improvement, specifically for analysis of vegetation in a dense canopy or in forests. And I'd be happy to give you further information if you contact us at Resi Applications, resiapps.com, and we'll maybe hear from each other later. Goodbye.